So, arbitrary code execution is now a reality in The Legend of Zelda: Ocarina of Time. Just want to start off this video by saying that I did not find this direct implementation of ACE. This project was spearheaded by fasch and NatalyaHasDied, although they had both direct and indirect support from people in the glitch hunting community. So I'm going to try to explain this in simplest terms I can, although for something like ACE, it's very complicated in nature, so I will be stepping through a bunch of code and talking about some lower level aspects of the game, but I'll do my best to try to make it digestible for everybody watching. So to start off with some foreshadowing, you will need this exact file name, and I will explain why much later, but it is important that every character has the right value. And you'll see that once I press end here, the values for all of these characters will be written to this address, and that is exactly what we want. So the glitch that allows ACE to work is called Stale Reference Manipulation, or SRM. This glitch is such a massive game changer. It's gonna need its own video. I'm planning to do that once we have enough information to fully understand it. But to give a little bit of an intro and how it relates to this glitch, Stale Reference Manipulation at its core is a glitch that makes use of the fact that actors and their code all live within a fixed space in memory. This space in memory is known as the actor heap, and within this space you will find actor instances, which is data relating to actors, and actor overlays, which contain code and data used by that code. So in an attempt to make this easier to understand, I'm going to draw some pictures to try to help visualize what's going on. So this space I mentioned called the actor heap, I'm going to represent as this box, where the start is over here and the end is over here. Now toward the beginning of the heap, you'll find the instance for Link himself. So this is the data that represents both child and adult Link. And beyond here you have space for any actor instance, so its data, or its overlay for its code. So in this game, what we call actors are pretty much anything that goes on the scene that you can interact with or are a part of the scenery. So actors include Link himself, enemies, NPCs, ladders, chests, gravestones, anything that is on the scene itself. So for this example I'm going to draw a little box that's going to represent the instance, so the data for a pot that Link can pick up. Now, I have on screen a live view of the game's RAM, and I'm at the location of where this pot in front of me is. And you'll see that once I pick it up, some numbers are going to start updating. And the ones that you see right now are actually for its position. These three over here, X, Y, and Z position. You'll see that they change rapidly when I move, and they change a little bit when I'm standing still because Link is breathing up and down. So the important thing to grasp from this is that when an actor is grabbing another, whether that be Link holding an actor above his head or a boomerang grabbing an actor, the actor that is grabbing will keep a reference to the location and memory of the actor that it is holding. And in this case, Link keeps a reference to the start of this pot in memory. Now, while this reference exists, various data is being written to the actor instance, including its position, its rotation, what is holding it, etc. Now, things get interesting with stale reference manipulation when you change rooms. And by doing that, you unload the actor that is being grabbed, while still maintaining that pointer that says that you are grabbing something. And when you change rooms, there's a good chance that something will take its place, like say the instance for a chest. And now you're writing data to something that wasn't originally supposed to receive that data. You can do a vast amount of things with this glitch, including editing the contents of a treasure chest, which GlitchesandStuff has done recently. And it also becomes powerful because you can edit the overlays which contain code. You can see here in this video by GNS for manipulating chest contents that this concept of holding an actor that doesn't exist anymore is achieved by doing a super slide into a new room and then letting go of the super slide to pick up the item as the room changes. And when you do this, like I showed here, you modify what is at that location in memory and change the value of what is there. So that explanation took a little bit longer than I was hoping, but it's really important to understand what stale reference manipulation is doing to be able to understand how it can lead to something like ACE. Again, stale reference manipulation will get its own video, but I hope that that was enough to at least grasp the concepts of what's going on. Now, with a basic understanding of what stale reference manipulation can do, we're ready to get into the actual arbitrary code execution. I've created here a macro of the entire setup, and as it plays, I'm going to step through how each part is relevant to the setup. Now, the actor that we are going to use as the entry point for our arbitrary code execution is going to be Darunia. So we're going to do the setup here in Goron City. We're going to start off with ISG. We're going to be doing a big hover. A large amount of this setup is just to get a pot that we're going to grab in a very specific location in memory. So there's going to be a very long hover up here, and I'm probably going to fast forward through a lot of it. But yeah, Nehru's Love here, I tried to skip using it, but turns out that using it is actually important for the allocation of the heap to get the pot where we want. So we're going to do a Nehru's Love super slide up the stairs, super slide teleport, and now we wait for Nehru's Love to expire, because you cannot hover with Nehru's Love. So I'll fast forward through this. So as Nehru's Love starts to expire here, you'll see some Chew hovers up. Normally dropping a Chew out of bounds will crash, but there's a tiny bit of ground underneath that I have to work with. Just going to be doing hovers and turning around to stay over that ground. Now that we're high up enough, we're going to start doing some bomb hovers in a second here. The goal is to get to the hallway where the Medi Goron is, who sells you the Giant's Knife. And the whole reason behind this is simply to enter the main room from that area to put this pot at this exact address that we want. Now, this setup requires this long hover. That's not to say that every ACE setup in the future is going to need this exact allocation of the pot, but for this specific example, this is what was needed. This is a proof of concept that can definitely be applied everywhere else, not just here in Goron City. Now as we come up on the last hover here, we're ready to side up into the hallway. We land on a little table. And we're gonna backwalk slowly to load the hallway. You'll see the bombable wall there. And we're going to enter the main room with this camera. This affects the allocation of the actors. And now the pot that we want to grab is exactly in the right location. So we're ready to proceed. So we're going to have Nehru's Love again. We're going to use that for the super slide off the pot. But more importantly, it's also going to affect the way that actors are allocated on the heap. The actor heap is very volatile, and pretty much any actor that you unload or load while changing rooms will have an effect. Now this is where SRM starts to come into play. Get a super slide off the pot, release as the room changes, and now we are holding nothing. But the location and memory of where the pot was is still being updated with various data. So we're going to make our way up to the top of Goron City. Just need to reload the main room by going to the boulder room, and this will just shift some actors around on the heap to exactly where we want. Now you'll see that as we make our way back into the main room, these values on screen are being updated. This is the Y rotation of the pot, so as Link turns left and right, that value will be updated. And our goal is to get it to an exact value, 5150. This setup by Neko made that much easier than it was before, so thanks to him for that. And now we will walk up here and shield drop it. Now, I've paused the macro because there's a lot to go over here, but we've dropped the pot with the angle exactly that we want, and now we're going to move on to the slingshot portion. Now, due to the way that we've spawned all of the actors with this whole setup, we know exactly where the slingshot seed will spawn. The spawn happens right when Link pulls it back on the slingshot, and we're going to be paying attention to the X and Y rotation of the seed. Now you'll see that as I turn to the right slowly, these lower two values are updating. We want to bring it to exactly the value that we want, and then we'll start looking down, which will update the X rotation until we get exactly what we want. 0807212D. That is exactly what we were looking for. So with that, the actor heap is finally completely set up. We can move into Darunia's room, get ready to actually execute the code. So before we can actually trigger the ace, there's actually one more thing we have to do. This setup actually requires two controllers to be plugged into the console. One on controller port 1 to play the game, and one into controller port 3. Ocarina of Time will read inputs on controller 1 and 3, and not 2 and 4. I'm not sure why, don't ask me, but it works for us. So, I have a plugin written by Glank to help visualize what's going on controller 3, and the corresponding values in memory for those buttons pressed. So, let's freeze the emulator. We're going to set the X coordinate on the control stick, so the horizontal axis, to 105, and the Y to 125. We're going to hold this exact control stick position, precise to the unit, and also hold D-pad up and C down. And you'll see that when I resume the emulator, the values for all those buttons pressed will update. 0804697D 00000804, which is exactly what we need. And now with controller 3's input held, we are ready to actually trigger the ace. So this specific payload is going to erase the hookshot from inventory. It started as a meme in my stream chat that Fasch vowed that the first thing he would do with ace is erase the hookshot, and he delivered. So I'm going to put the address for the hookshot on screen. That A right there is the hookshot. And if we take sort out, which is important, walk up to Darunia, hold L, Z, then press A to talk. Now our payload has been executed. You see the A there has turned to FF. Gonna finish talking. And you'll see that our hookshot is gone. So doing ace in this way has caused some weird side effects. You can see that the camera is locked, Navi is a strange color, and he sounds a bit like Dark Link. You can also see that I can target myself, spin in circles, and when I press A, Link will do a little hop. So this is actually just a side effect of the way that this code was executed, and I will show exactly how this happened, but this was not an intentional part of the payload. And also you have to hear Dark Link yawn, so I'm gonna wait for that to happen. I'll cut to it. Very nice. So now I'm going to get into exactly what happens when the payload runs. From this point on, things might get a little bit confusing, but I will try my best to make it as easy to understand as possible. So this window on the right here is the breakpoint window. This window allows us to halt the execution of the CPU on the N64 and step line by line and see exactly how it's processing data. You'll see on the right here this section, general purpose registers. This is space where the CPU can put numbers that it's going to use to do operations on. So it will load values from RAM into registers and store values from registers into RAM. The only other really important concept I want to get across before we step into this is that these instructions are really just numbers. This window is displaying them in a way that is readable to me, but if I were to put the same address of this ORI instruction into RAM here, you see that it's just a number. So 37180024 is how you represent this instruction in numerical form. So given that, I think we're ready to start. I think before we get into how the code is executed, we should talk about what happens normally here. Now, when you talk to Darunia, there will be a point where Darunia will jump to a specific place in execution, depending on if you have an item in hand or not. If you have sword in hand when you talk to him, it will load this address, 801F8A08, and jump there. I can demonstrate that here by walking up with sword in hand, putting a read breakpoint, and talking. And you'll see here that it loads this address into register T6, and then jumps to it, which happens to be right down here. Now, if you recall earlier, we used stale reference manipulation with a pot to set the value somewhere in memory to 5150. If you look here, we have actually used the pot to change the lower half of this address to 5150. So when you talk to Darunia with sword in hand, instead of loading the address of where it's supposed to go, it's going to load the address of 801F5150. Now to demonstrate, I'll put another read breakpoint, walk up to Darunia, do the button combo. So now when we get this load into T6, we're going to get the address 801F5150, which is what we modified with the pot for SRM. So instead of jumping right down here to 8A08, we're going to jump up to 801F5150. Let's follow that. Now, this here is not valid code. We are now in the data section. This is stale data not being used. However, if you remember just a few moments ago, we used the X and Y rotation of a slingshot seed to set some very specific values. Now, if you have a look in RAM, we set 0807212D. Those were the values of the X and Y rotation of a slingshot seed. And that is the numerical form for jump to 801C84B4. Now, if you remember from earlier, we had that dark link side effect, and that comes from the instruction directly following this jump. This here, store word to coprocessor 1, it's actually writing the value in this register here to link's address, the start of link's instance. This value is from the Z rotation of the slingshot seed. This is just what it happened to be. Thankfully, it didn't cause a crash. It just causes the dark link stuff, and it's not the end of the world. So I'm showing here on the left the start of link's instance, and you'll see that when I run that leftover instruction, these values will get written to the very start. And the dark link side effect happens because we're overriding link's actor type. If link's actor type is anything but player, he'll have that effect where he sounds like dark link, and Navi will be a different color because she doesn't have a lookup for that actor type. Being in this dark link state is pretty limiting. All loading zones will deactivate, but thankfully we can just pause and save warp out. Now, continuing our execution, we are going to go from the slingshot seed up to here. Now we've jumped from the location of the slingshot seed up to this area in memory, which is where inputs are tracked. If you remember, before we talked to Darunia, we held L, Z, and A. When those buttons are held, you get value A020, and that interpreted as a MIPS instruction will give you this here, which will store 0 at this address, which is fine. And we get add 0 into S4, which is just a harmless instruction. Our goal here is to just not crash, so this does nothing. And now we have a bunch of zeros, and zeros means NOP, or no operation, which is great for us, so nothing happens. Now, the magic happens at controller 3's input. If you remember earlier, we were holding a very precise control stick position and held D-pad up and C down. The values for those inputs, when interpreted as a MIPS instruction, is jump to 8011A5F4, and this instruction preceding it. So we jump down, and then we run another harmless instruction that will not cause a crash. And now, this is where the payload is. You remember at the very, very beginning of this video, we had set a very specific file name. If you look at the values of that file name we set at the very beginning, you see we have 08012850, which is this jump instruction here. This jump will get us back on track to running actual code, as we are still kind of in a garbled mess of data. And we have A3, B6, B6, 3D. This is the actual payload. This will store the byte FF to the location of the hookshot slot in the inventory, thus deleting it. So at this point, we jump to a new location. This is going to be an actual function now, so we're leaving the data area and going back into some functions. And then this store byte instruction will actually write to the hookshot, and at that point the hookshot is erased. And now we jump to this location in memory. So this function isn't very useful to us, other than the fact that it will help us get back on track to where we were with execution before we altered it. So we jump to the end of an already existing function to make use of how it's returning to go back to where we were. So if we just follow this a little bit, we'll do a jump to return address. So at this point, we're actually back on track with execution. We've avoided crashes completely. And this whole thing will actually happen 6 times, as it takes 6 frames for him to put away his sword. We're on the first iteration. You'll see if I hit the go, we'll go to the next frame, it's ran, again, 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 again. And we're done. Payload has been executed, and you just have to clear the text, and then you're good to go. So that was a lot of information thrown out there at once. It might have been kind of hard to follow. So I'm just going to try to simplify things and draw it out to hopefully make it easier to understand. So I'm going to use a black box to represent RAM as a whole. I'm going to split it up into a few important parts. Now first off, we did a huge setup in Goron City just to rearrange the way that actors were organized in the heap here. And we did all of that just to make sure that actors end up exactly at the location that we want. Now first off, we use stale reference manipulation to modify a value in Darunia's overlay that is normally used to jump to if sword is in hand. So say this represents Darunia's overlay. We use stale reference manipulation to modify a value in the data section here that is normally used as an address to jump to for execution. Now when you talk to Darunia with sword in hand, instead of jumping down here to where it normally goes, we used SRM to change the address so that we jump execution up here. Now right after we dropped the held actor, we started aiming with the slingshot to get very specific values. All of that heap manipulation was also to make sure that the slingshot seed, when pulled back on the slingshot, loaded exactly right here so that we could set its X and Y rotation to a value that we wanted. Now using the X and Y rotation of the slingshot seed, we were able to form an instruction that will jump us all the way up here to where inputs are tracked in memory. And by holding specific inputs on both controller 1 and controller 3, we were able to direct execution down here and then to the file name over here. Now the file name that we set at the beginning of the video had very specific values for the payload to actually erase the hookshot, and another to jump up execution up here to actual code, which will help us get back on track. And at this point, execution will find its way all the way back down to the Darunia overlay, and things will run as normal without crashes. Now, while erasing hookshot is a good meme, you have to keep in mind that we can craft a lot of things with the file name, which is our actual payload. So I'm going to show some examples of things that we have already. You'll notice here that on my quest status screen, I only have Zelda's Lullaby. However, you'll see that after I execute the glitch, you'll see that when I pause, it is now completely filled. With this file name, we'll be able to change the language. You'll notice that the game is in Japanese currently. And now the game is in English. With this file name, we'll write some pretty interesting stuff to Child Link's equipment. You won't see the effects until after a save warp, so I'll cut to that. You'll notice that I have a pretty nice blue colored tunic. I slide around because I have hover boots on, and my shield is upside down. And with this file name, we'll be able to get the mirror shield as child. Although it's visible, that is the mirror shield. So Twinrova as child is possible. Now this one is a personal favorite of mine for our final one. I love this so much. Please excuse the emulator lagging. And away we go. This is 100% possible in the game. It's amazing. You just float in the air. So all of this new information leaves us with a couple of unanswered questions. First, what is the future of ACE and OOT? Our current method of implementing this is pretty limited in the number of instructions we have to work with. So while we can do a lot, as demonstrated in this video, it's not as big as some other ACE you might have seen. Now most of this shown here is just a proof of concept, and it can be expanded through a lot of methods using SRM. And one of the main theories we have for expanding the number of instructions we can have is to use the longer Scarecrow song as a method of some form of a payload. It seems to be pretty restricting in the instructions that we can write with it, but we'll see how it goes. Now the other question is, will this affect RTA speedruns? I'm of the opinion that it will not. I think I've demonstrated in this video how precise a lot of this stuff has to be in order to make a payload. It's something that I don't see becoming really RTA viable ever, personally, but I've definitely been proven wrong, so we'll see how that goes. SRM in general, though, is definitely going to find its way into speedruns, so I would not count that out. Researching and learning about SRM has been some of the most fun I've had in this game in a long time, so I'm very glad to have been a part of it, and it's really cool that it was able to enable something as big as ACE in this game. Just want to thank all the people involved with the research for SRM, including but not limited to GlitchesandStuff, NatalyaHasDied, fasch, Thero, Exodus, MZX Rules, everybody in the OOT glitch hunting community, really. We've been working together really well to find out as much as we can about this glitch and what we can do with it. And shoutouts to Nat and fasch, who are the two who really put in the most work into making this ACE work in general. So, huge props to them. If anyone has any questions on this stuff, feel free to find me in the OOT Discord. I'm always available for questions on this stuff. So yeah, I guess that's everything.